Hello everyone, my name is Lu Li, a PhD student at the University of Pennsylvania, advised by Dr. Yongchen. Today I'll be talking about synthesizing evidence for rare events, a novel zero-inflated bivariate model to integrate studies with double zero outcomes. Let's start with a real-world case study taken from the Cochrane database of systematic reviews. The authors explored the potential use of probiotics as a treatment for Clostridium difficile-associated diarrhea, also known as CDAD, caused by antibiotic use. And specifically, they want to know whether probiotics cause any side effects when used to treat CDAD. You can imagine that this meta-analysis was in fact an OHDSI network study where each data partner contributed some estimates that are being pulled together. And as you might know, adverse events are often very rare. In fact, among the 32 studies in their meta-analysis, 10 of them have no events in both the treatment and control groups. Such studies are called double zero event study, or DZS. Double zero event studies often arise in OHDSI research. In fact, the larger the OHDSI network study is, the more smaller sites will participate, and the more likely it is that we will see these double zero scenarios occur. For example, the Darwin EU, as we've seen in the previous presentations, is a federated data network consisting of many healthcare databases across the European Union. And they typically have smaller cohort sizes, making them especially likely to encounter double zero studies. The problem is, double zero studies create challenges for estimating commonly used effect size measures, such as relative risk and odds ratios, due to the division by zero error. So the question then is, how should we deal with the studies that had no events? A natural approach might be to exclude them from the analysis, and is in fact commonly done in practice. However, there have been studies showing that the exclusion of double zero studies impacted the conclusions. And furthermore, since we want network studies where anyone can contribute, we need a solution to handle the double zero studies. One approach to include the double zero studies in the analysis is to use some one-stage methods, for example, the bivariate generalized linear mix models, or BGLMM. The BGLMM is a bivariate random effects model that jointly analyzes the risk in the treatment and control groups. And specifically, the number of events for the treatment and control groups are denoted as Y and follow a binomial distribution, with N being the sample size and P is the event risk. And event risk are modeled using a fixed effects and random effects component, and the parameters of interest are the fixed effects and random effects, and they can be directly estimated using the maximum likelihood estimation. However, one limitation with the bivariate generalized linear mix model is that it treats all the double zero studies similarly to the other studies. The question then is, should we treat the double zero studies similarly to the other studies? The short answer is no, and let me explain why. The rationale here is that the sample size of the studies are informative. And let me explain this intuition through a simple example. Assuming an event rate of 1%, the chances of observing a cohort with 110 double zeros is 1/3, which is probable. Whereas the chances of observing a cohort with 1,000 double zeros is around 4 out of 100,000, which is very unlikely. And therefore, the actual event rate for the large double zero studies might be much lower than 1%, indicating the fact that they might be coming from the extremely low-risk population. So our conclusion is that we should not treat all the double zero studies as the same as the other studies. So to differentiate the large double zero studies, which might come from the extremely low-risk population, we use the zero-inflated models, which separate the observed zeros into two distinct categories. The first category of zeros are known as the at-risk or chance zeros, which correspond to the latent group of population who are at risk for an event, but have a recorded count of zeros by chance. And the second group of zeros are known as the structural zeros, which represent individuals who are not susceptible to a specific event, and thereby having no chance of a positive event count. And here is the formulation of a zero-inflated binomial model, and the event number follows a binomial distribution with probability 1 minus pi, or it is definitively 0 with probability pi. So our method combines the zero-inflated models with the BGLMM, and is called Zero-Inflated Bivariate Generalized Linear Mixed Models, or ZIBGLMM for short. So our model is a two-component finite mixture model, and given a double zero study with zero event counts for both treatment groups, it either comes from the at-risk population or it comes from the low-risk population. And still, the parameters of interest are the random and fixed effects and can be estimated using the maximum likelihood estimation. The advantages of our method are twofold. First, no studies are dropped from the analysis. And second, our method models the population heterogeneity, by which I mean the existence of a low-risk and an at-risk population, through a data-driven approach. Now let's revisit the case study. Recall that 10 of the 32 studies are double zero event studies with sample size ranging from 18 to 144. In their original analysis, the authors excluded those 10 double zero studies and concluded that probiotics reduced the risk of adverse events by 17% with an RR of 0.83. Using our method, we included the double zero studies, and the RR we obtained is 0.70. So our conclusion is that including the double zero studies could potentially lead to estimates that differ by a large degree, i.e. greater than 0.1. So in summary, zeros in the double zero event studies may arise due to population heterogeneity. And second, ZIBGLMM offers a more comprehensive analysis of the available data. For OHDSI, ZIBGLMM is especially useful for larger network studies and for studies involving rare events. If you have any questions, please feel free to stop by my poster number 506. Thank you for your attention.